and welcome to the Johnson Controls Blue Water webinar for February 2022. Each monthly webinar is a fun, informative, and interactive digital experience for water utilities to learn more about new technologies, software, services, and best practices. The Blue Water webinar is brought to you by the Water Infrastructure Technology team of Johnson Controls. I am Craig Hanna, and I have the great privilege of serving as the engineering manager of the team of this subject matter experts. I have been designing water loss optimization projects for utilities for the past 20 years. And with me today are two of my valued teammates, Audrey Noel and Jonathan Gunn. Audrey, would you please tell us more about yourself and your experience in the water industry?
Hey, I'm Audrey Noel. I'm the business development leader for the Water Infrastructure Technology team here at Johnson Controls and leading operations. I've been in the industry about 6 years, and I've been directing operations for decades. Jonathan?
Yeah, thank you, Audrey. My name is Jonathan Gunn. I have the privilege of being a market manager on the water infrastructure team. I have about 12 years in the industry, and like Craig, I serve in a number of different capacities within AWWA, including as the current vice chair of the Customer Metering Practices Committee, current chair of the C712 Single Jet Meter Standards Committee, and I co-author a number of manuals as well. So appreciate everybody being here with us today. Are seeing some familiar faces in the attendee list, so those of you I say welcome back. To those who may be joining us for the first time, welcome to the webinar. And we recognize that there may be some folks that may not be familiar with the On24 platform, so I did want to review that briefly. So you should see 5 windows in front of you here. Should be looking pretty similar. Right in the center here, you should see some orange dots popping up on your screen. This is the slide deck window. This is where a majority of the action will happen. You'll see the slide decks as we progress through the webinar. You'll also see any poll questions as they arise. That's where you'll answer polls. You'll see the answers for those polls as well. And then in the upper left, you'll see the media player. That's where you're currently seeing me talk, and you'll see the other presenters as we go through the presentation. Below that is a book a meeting function. So if there's something, a question on your mind, or you'd like to learn something more, or whatever the situation may be, maybe you feel an email or a message just won't do it, please book a meeting with us. We're happy to talk with you and see how we can help. To the upper right of the slide deck are webinar-related content. This is a number of files that you can view and download at your leisure that are all related to not only this webinar, but past webinars as well. And then below that, we have a Q&A box. So, mind burdened by a question sometimes ceases to move forward. So we've built in a number of stops in this webinar to answer any questions that you might have. So please use that feature. And then finally, along the bottom, we have a number of icons. Some of them are redundant for windows that you're seeing now, such as the media player, slides. But some of them are a little new, and email us, earn CEU credits, and take a survey, most notably. So we do ask at the end of the webinar, you take a survey. We're always looking to improve this series and make it better. So please take a survey, let us know how we did. And if you are looking for CEU credits, please use that link as well, and we'll get a certificate to you. And then, if for some reason, all these windows, you can move them around, you can resize them, you can really make it your own. If for some reason you accidentally get rid of one of them, just go to that bottom icon bar, and that's how you would get those back. So with that, Craig, do you want to talk us through the agenda for this morning?
Yeah, thank you, Jonathan. Our team is excited about the webinar today, and we hope that you are too. We had so much fun putting it all together for you, and we know that you will find it both useful and informative. We are focused on safety here at Johnson Controls, and we want every one of you to go home tonight to be with your family. So we ask our old friend Tom Kelly to come and discuss water utility worker safety. Tom has spent his career working in water utilities, and he is also the chair of the AWWA Metering Standards Committee. Tom may know something about riding motorcycles to AWWACE for a good cause, so don't be too surprised if that topic comes up during our chat with him. And following that, our team will discuss best practices for small and intermediate water meter management. And we hope that you will join us in the discussion using both the Q&A module on your console and through our poll questions. Next, we've asked Dawn Groves, Martine Casillas, and John Baker from Camstrup to join us for an interactive discussion with you, the audience, about their company and their innovative ultrasonic water meter product line, the roadmap they have for future releases, and their thoughts on the state of the water industry today. And we decided to change the format of the webinar for this month and not spotlight a water utility. Most all of us have been personally affected by COVID recently. And between the pandemic and the severe winter storm Landon that dumped large amounts of snow and ice across much of the USA earlier this month, we realized that most water utility staff members were at their limits. And all of us at Johnson Controls truly appreciate those of you who work hard every day to make sure that we have clean water to drink. And hopefully things will improve soon and we can resume with the Water Utilities Spotlight segment next month. And now I would like to introduce to you Mr. Tom Kelly. Tom, you have spent most of your career working for water utilities. Could you please tell us more about your background?
Well, good morning, everybody. As Craig said, my name is Tom Kelly. I started actually my career as a mechanic. I went to vocational school, and when I was in the Army, I started working on armored personnel carriers and tanks. I find I like working with the heavier stuff better, and I got out. I became a field tech for Caterpillar, and I started with the Washington Suburban Sanitary Commission as a mechanic because they had a fleet of equipment they were using to run a compost site and needed experienced mechanics to maintain that equipment. So the mobile equipment has a very short career ladder, and I decided that if I wanted to move, I needed to get some additional training. Had a lot of technical training, but not formal education. And so I started going back to school. WSSC had a very generous educational assistance program, and I utilized that. Eventually got myself a master's degree from the University of Maryland. WSSC paid for all of it, except parking sticker. But I figured, I could spring for the parking sticker if they would pay for all the rest of it. And so I moved over into meters and started working with those and actually spent my career 37 years with WSSC. And at AWWA, I, as Craig said, chair the Meter Standards Committee, sit on several of the subcommittees, and I also hold a seat on the Standards Council. As you can see from my attire, this is my Water Buffalo vest, which I wear with a great deal of pride. I've been a Water Buffalo since 2007 and have made every ride since then. And I had read an article in a trade magazine about these guys that there's three guys that came up with an idea and started doing the ride. I realize that I'm preaching to the choir here, and many people understand how many people on the face of the earth don't have safe, reliable water available to them on a daily basis. So Water for People is all about trying to change that. And so we help raise funds for the Water for People. We have grown to the point now, which started as something pretty informal, to the point where we now are a 501c3 organization, because when you start raising that much money, the government really wants to know where it's coming from and where it's going. So riders absorb all their own costs during the ride. All the meals, hotels, gas, everything is all out of pocket in order to maximize the contributions that are going to the cause. So if anyone is interested, throw a commercial here. Our website is www.ridewithpurpose.org. And we are currently active insofar as accepting sponsors for, you can see the different patches, and believe me, this vest is covered with them. The back of it entirely with sponsors, and we truly are a handful of people out to change the world. When Craig asked me about giving a safety brief, the very first thing that came to my mind was something that I believe that it's necessary to completely and repeatedly beat the drum to our crews that are working in the field in confined spaces such as pits and underground vaults. If your partner or crewmate is in the hole and they become unresponsive, incapacitated for one reason or another, stay out of the pit. Get help. And I realize that that is an extremely difficult directive to follow. Everybody wants to help. That person down in the pit or the vault is your friend, your partner, your crewmate, whatever, and you want to help get them out of there. But the best way that you can get help is to actually get help. Because we want to avoid the domino effect of people just going in there and continually succumbing to whatever incapacitated the first person. And so we don't want to have that domino effect. And the bottom line is that we want everyone to go home safe at the end of the day. That's my short and brief safety talk.
Well, thank you very much, Tom, for that discussion. Some great points there, and absolutely thank you again for all the great work that you do with the water buffaloes and your fellow water buffaloes. I had to get rid of my motorcycle when my daughter was born, but I do hope that someday I'll be able to get another one, and I do intend to ride with the buffaloes once that happens. So it's probably going to be a little while, but
yeah, well, that's great. Believe me, I understand. When my kids were growing up, I took about a 10-year hiatus from motorcycles just because they needed their dad to be around, and yep. It was a competition. So there was no competition. I put the bike away, right. And once they grew up a little bit, then I got back on it again.
Yep, that's the plan. So, well, thank you again, Tom. So none of us on the water infrastructure technology team are embarrassed to say that we have a passion for water meters. And as a matter of fact, if you've heard Craig and I present before, we usually will refer to ourselves as outright meter geeks. And I know Audrey maybe doesn't put herself in that same category, but I can tell you she still has the same passion that we do for them. Your meters are literally the cash registers for your utility. So it's critical to maintain the accuracy of your meters for the financial health and stability of your utility. As Craig mentioned earlier, our plan is to discuss best practices for small and intermediate water meter management today in order to help you with this challenge. So as a brief aside, we will discuss best practices for large water meters in our March and April webinars. So we're planning on that being a two-part series. And before we begin, let's just talk briefly about meter sizes. I just use the terms small, intermediate, and large when describing meters. So what does that mean? A small meter is defined as anything 1 inch in size or smaller. And you're typically going to find these most often at single-family residential locations. An intermediate size meter is defined as either an 1.5 inch or 2 inch meter. And you typically find these in multifamily residences, maybe some light commercial applications. And lastly, a large meter is defined as anything 3 inches in size and larger, although if you have an 1.5 inch or 2 inch turbine meter or a 2 inch compound meter, those are also classified as a large meter. And for those small and intermediate meters, and they certainly come in a variety of choices, don't they? So while there are additional types of meters available worldwide, we have kept the focus of this list to meters that are currently available in the United States for the purposes of our discussion today. We aren't going to take a deep dive into the inner workings of these meters or the various technologies today. However, I think it's safe to say that utilities are spoiled for choice when it comes to the available selection. Each meter technology has its pros and cons, but depending on a number of factors which exist in your utility, it's usually not hard to find a technology that checks at least the majority of the boxes for your utility and the needs that you have. Arguably, one of the biggest factors when it comes to selecting a meter involves water quality in your distribution system. I will fully admit that we're not going to do a deep dive into water quality here. We could probably spend an entire webinar just talking about various water qualities and how they affect different types of meters. And a matter of fact, we're actually thinking about doing that on a future webinar. So stay tuned for that. But we certainly felt that it needed to be mentioned here because it is a pretty large factor. And it's really anything that you see on the slide here can have an adversely affect your water meter accuracy, particularly if you use mechanical water meters. If you have buildup of scale in the meter, if that causes the meter to become blocked, those things are never desirable because you're clogging up your cash register, and they can be surprising. Not oftentimes you see it coming. And here are a couple of examples. The photograph on the left shows a multi-jet meter, which has scale deposits which have formed across the entire wetted area of the measuring chamber. And then thanks to the scale being there, sand and iron deposits have also accumulated on top of that scale. So that meter was pretty well clogged up. The meter to the right, it was a different meter, and that's where there were a lot of biofilms in the water. And so those formed throughout the measuring chamber and clogged the basket strainer as well. So in both of these cases, they were really having no registration pass through these meters, so they went and checked it out, and this is what they found. In this image, you see a pretty advanced example of tuberculation. This is a 2-inch positive displacement meter, and there are different, aspects of your water quality that may lend themselves to, tuberculation happening more than others. Usually we don't see too many that are like this, but it is possible. So the long story here, if you have questions about your water quality and how it may affect your chosen water meter, we do recommend that you arrange for a water quality sample to be taken and then analyzed by a professional laboratory. Once you get those results from the laboratory, share those with your meter manufacturer to ensure that you're not going to run into any complications should you end up moving forward with that meter for your system. And those complications can include things like anticipated life, maybe even the warranty. So it's things you want to check into before you move forward. And as I mentioned, water quality is probably one of the big ones, but there are certainly many other considerations which must factor into you as a utility in your decision of what technology you intend to use. There's a seemingly endless list of different things that, whether they be needs or wants or desires of a utility, but some of the more common ones that we run into when we work with utilities are things like meter material, flow characteristics, desired technological features, and product warranties. So modern water meters can come in a number of different materials: composite, brass, epoxy, ductile-coated iron, epoxy-coated ductile iron, and stainless steel are a few. And there may be pros and cons depending on a number of factors in your utility, which those things can include installation experience of your meter techs, existing meter sets and how they're set up. Does your system have excessive tensile or compressive forces in your distribution system? And obviously many others that can really lend themselves to having an effect on the material that you want in your system. Flow characteristics introduce another factor to be considered. What is a typical consumption profile for your customer? Does it align with the AWWA M6 manual, which for a typical residential service suggests a 15, 70, 15 weighting for low, medium, and high flow rates, respectively? Do you need the ability to capture flow at extremely low flow rates? Your answers to those questions and others will help to shorten this list of possibilities for you. Battery life is another consideration for today's meter. Static or electronic meters are literally run by them. Everything from collecting and storing meter reads, if they have the capability in the meter itself, to providing power to the actual measuring element of the chamber are all run by battery power. Whereas mechanical meters don't rely on a battery to measure the water that passes through the measuring chamber, and they may or may not have a battery in the register of the meter itself. It should be noted that most electronics have a stated 20-year battery life, and mechanical meters, again, depending on a number of factors in your system, it can have upwards of a 20-year recommended service life. So in theory, the differences should be pretty negligible. However, if for some reason you're not able to replace meters in year 20, a mechanical meter will keep reading, whereas an electronic meter may not. Technological features are another aspect. Do you want the ability for remote disconnect in your system? Do you want the ability to gather temperature or pressure readings? You know, the industry is in such flux, particularly over the last 10, 15 years, and there's so many new developments and features added to these meters all the time. But it's not necessarily, you know, an equal distribution among meter types. So selecting one that will meet your goals is definitely something to consider. And the last one we'll discuss today is meter warranty. Some meters have a 20-year warranty, which is typically prorated in some way. 10 full, 10 prorated is usually pretty common. However, some types of meters have a shorter warranty and might be more based on the meter age and or the amount of consumption that passes through. Whatever technology you select, make sure that it meets your desired criteria. And by the way, a little plug here, Johnson Controls has been conducting a research project, we call it Static Meter Research Project, which is in an 11th year of its study, and it compares static versus mechanical meters at typical residential locations. We do have a number of utilities across the country which are participating in the study, so it is free to anybody who's interested. There's a distribution list for that that sends quarterly updates, so if you are interested, please be sure to send us an email at bluewater@jci.com. We'll be sure to get you on there. So now we've covered some of the more common rationale behind selecting a meter. You've made the best decision for your utility, and now it's time to implement that choice. So we know that you are very busy. You know, staffing resources are seemingly always, you know, out. However, we strongly encourage you to take the time, follow the manufacturer's installation guidelines, and to make certain that your water meter technicians at your utility have the proper training in order to implement this very important choice that you just made for your utility. Depending on the type of meter that your utility uses and how a water meter is installed may directly affect both its accuracy and its useful life. So, Audrey, you've got a lot of experience in this realm, you know, across the country. Do you want to walk us through some considerations for small and intermediate meter installation?
Sure, thanks, Jonathan. Well, both single jet and multi-jet water meters must be installed level and horizontal, typically with not more than 5 degrees of inclination in any plane. Meter accuracy would be affected, and the useful life of the meter will be shortened if that threshold is exceeded. I'd like to thank my friend Aaron Burke for sharing the photo at the left with the wall of multi-jet meters mounted vertically. While we're focusing on small and intermediate meters today, it's worth mentioning that the compound meter should also be installed level and horizontal. The crossover valve in a compound meter is not designed to work against the pull of gravity. Consequently, compound meter accuracy and useful life will suffer. You may be long retired and busy spoiling your grandchildren or traveling the world by the time that water meter you installed today needs to be replaced. But that water meter will eventually need to be replaced at some point during the next 15 to 20 years. As such, we encourage you to consider the next person. Will that person have to take extra time and make an extra effort to replace the water meter? Will cutting a corner today serve only to cost the utility much more in the future? If your utility is migrating from manual reading to either mobile AMR system or a fixed network AMI system, and if your water meters are set in outside meter boxes, cans, crocks, or tiles, it's a best practice to capture the GPS coordinates of each water meter setting if your utility hasn't already done so. That's because nobody from the utility may need to visit the meter setting for the next 2 decades, and the location of the meter setting may become lost. Having the GPS coordinates for the meter will make the water meter and endpoint replacement process both quicker and easier, since less time will be needed to locate the site. If the water meter is set in either a basement or a mechanical room, document as much as you can about the location in the notes for that account. I'm thankful to say that we don't find many examples of theft of service events, but we do manage to find a few on most every project. On one of my first water meter projects, we discovered an individual had installed unmetered bypasses on the water, natural gas, and electric services. The utility called the local police to investigate, and the police discovered both a whiskey still and a casino gaming operation at the residence. So we recommend that you train your water meter technicians to look for illegal bypasses whenever they're working at a setting. We sometimes find refrigerator magnets placed around a water meter in an effort to decouple the register drive magnets on a mechanical meter. Magnetic tampering for both mechanical water meters and for small electromagnetic is possible, but it takes a very powerful magnet to affect a water meter, like one you'd find inside an industrial electric motor. This is one of my favorite water meter installation images. I took it at a utility in Illinois that uses meter cans, and this was a relatively common setting at that utility. The diameter of the meter can is 10.5 inches, and the meter setting is 3 feet deep. I don't know of anybody who could change out that water meter except perhaps a professional basketball player. And I'm relatively certain that once LeBron James or Steph Curry retires, they probably won't seek work as water meter installers. The meter setting will have to be completely dug up in order to replace the meter, and it's improbable that those meter cans could even be reused once they're excavated. It would have been far better to purchase and install a larger meter box during the initial installation. And I absolutely despise this photograph. The meter box is too small for the water meter setting when it was originally installed, and the box is clearly too shallow. Even with a very low profile static water meter, the lid can't fit on top of the box. Over time, you can see the soil around the box shifted and caved the box walls inward. Instead of replacing the broken box that was also too small when the original water meter was replaced, the meter technician chose to install a new static water meter and walk away. If you see a meter box or lid like this that needs to be replaced, please do your personal best to have a professional-looking installation. And endpoint should never be left sitting on the ground either. For best AMR or AMI system performance, a through-the-pit lid mounting is the most desirable method. If that's not an option, then mount the endpoint on a fiberglass rod, a section of PVC pipe, or on a length of rebar. Place the endpoint as high in the meter box as possible and use a polymer lid. Depending on the type of the lid, it may either need to be replaced or modified for an AMR or AMI system endpoint. Oh, and remember that composite meter bodies may require 2 grounding clamps and 1 grounding wire for inside meter settings in older facilities. Be sure to include both the material and the labor costs for the grounding clamps and wire into your project. You don't need grounding clamps or grounding wire for outside meter settings. Craig, do you want to take us into operations?
Oops, there we go. Yeah, thank you, Audrey. So speaking of meter testing, actually, this is just advanced. All right, there we go. Regardless of the meter type that your utility uses, we do recommend you test a statistically valid random sample of your 2-inch and smaller water meters every year, because doing so will give you confidence in the accuracy of your meter population and will help you to maintain your billable usage and billable revenue. It may also help you to avoid a more expensive mass meter replacement program in the future, depending on how you do it. Another important point to make here is that meter age usually has little bearing upon meter accuracy. As I mentioned, I've been in the industry for 12 years here, which compared to a lot of folks is relatively short time. But during that time, I've seen some very old meters, 20, 30-year-old meters, which are still AWWA M6 standard applicable. They meet those standards that they did when they came out of the factory. And I've also seen some newer meters that are less than 5 years old, which have failed to meet those standards and have lost their accuracy. So for mechanical meters, typically what we find is it's a combination of both usage and water quality that will affect accuracy the most. Remember, mechanical meters are devices, they're mechanical devices, and they're affected by friction and wear, debris, scale, biofilms, all those things can mess with those mechanical components and accelerate accuracy loss. We recommend that if your utility does use mechanical meters, that you review the total registration at the end of each billing cycle. Any mechanical meter that is at 95% or more of the manufacturer's repaired meter accuracy registration limit should be scheduled for replacement. For static water meters, there's really no moving parts to fail with usage. Age in that situation does come into play a little more, however, again, from the standpoint of remaining battery life. As we discussed earlier, without a functioning battery, static meter is not able to register consumption. So unless they're replaced in a timely fashion, you may inadvertently cause an issue for yourself regarding the ability to bill your customers. We do recommend that you take careful note of projected battery life for your static meter and implement a replacement plan in order to avoid any lapses in the reading abilities. And while we're talking about meter testing here, let's discuss some of the best practices for accuracy testing. Really, first and foremost, if your bench looks like the photo you see in front of you, it is long past time for you to scrap it and purchase a new one. Water meter test benches are closed circuit tests, so you really can't expect to have accurate test results if you have things like athletic tape, plastic bags, towels, maybe a t-shirt, things that you find around the shop, trying to keep water in that circuit and, keep the water from spraying the operator as you're testing meters. So, if your bench looks like this, it might be time to think about getting a new one. Secondly, let the AWWA M6 manual be your guide. I touched on this manual earlier, but the M6 manual really is a standard for our industry, and it's derived from years of experience and mountains of research data. So if you follow it closely, there will be little ground for one of your customers to dispute the test results if and when they get a higher bill because that meter is no longer there and now they have a more accurate meter that's reading their consumption. A critical point I'd like to make when it comes to bench testing water meters, and unfortunately a mistake I've seen made countless times, is please do not start with a high flow rate test. For the benefit of anyone on the call who may not be familiar with water meter testing standards, typically each meter is tested at a minimum of 3 flow rates: low, medium, and high. The exact flow rates in terms of like gallons per minute will depend on the size of the meter, the type of the meter, per recommendations from both the AWWA M6 manual and from the manufacturer. But the concept is the same in that you obtain accuracies for each individual flow rate, and then you blend those into a weighted average per guidance of either the AWWA M6 manual, that 15-70-15 that I talked about earlier, or if you have flow profile data for your utility, use that weighting to properly calculate that average. We recommend that you purge the air out of the line at or below the minimum flow rate that is required for the test. Once all the air has been purged from the line, start with the low flow test, followed by the medium and high flow test. The biggest reason not to exceed the low flow rate test is that you may inadvertently cause yourself to overestimate a meter's accuracy. By starting with a high flow rate for your test, any debris or sediment in the measuring chamber that may have been causing that low flow side of that, of the meter to fail may inadvertently be removed. So any debris, scale, things like that may get blown out of the meter before you're able to test that flow rate. We fully recognize that it will take a greater investment of your time to do it this way, but we've simply seen too many times over the years where the patience has been rewarded if you do it that way. So real quick before we keep moving, just a quick poll of those of you out there. If you're a utility on the call, do you currently have a regular testing program for your small and intermediate size meters? And if you do, what does that look like? Is it you test one-offs? Do you test full samples? Do you have a bench but no testing program? Or do you not test meters? So if you want to mind, just take a quick moment here and just let us know what you do, and we'll just give it a few minutes here. So. Got some, oh, there we go. Starting to get some in here. There's 1, 2. All right, give it a few more seconds here. All right. Got the Jeopardy song playing in my head. All right. 3, 2, 1. All right. Looks like, oh wow, okay, pretty even distribution here. About a third and all right. So nobody tests one-offs, but some folks doing full samples, some doing they have a bench, no testing. Okay, we'll appreciate your feedback on that poll. So while we believe that testing statistically valid random samples are excellent indicators of system performance, there will inevitably be moments where you'll want to test just specific meters. If your utility already has a data analytics software package with a fixed network AMI system installed, accounts with unusual usage patterns are brought to your attention daily. If your utility does not have a data analytics software package, even if you have a mobile AMR or fixed network AMI system installed, it's still well worth your time to regularly review the usage data and create queries of that data. For any account in which the usage for the most recent billing cycle exceeds plus or minus 10% of the historical usage for that account for the same seasonal billing cycle, aka make sure you're comparing winter to winter, summer to summer, spring, spring, fall, fall, right, to account for those seasonal adjustments. But assuming it's plus or minus 10% of historical usage for that season, it is well worth your time to investigate why. Is something adversely affecting meter accuracy, or hopefully not, but potentially the entire meter reading system? Has the way in which the facility that you're metering uses water changed, that it may necessitate a change in the water meter type or size for that utility? The best example I have to illustrate one of these situations is from one of our customers in Mississippi. Pepsi had a bottling plant that required a 12-inch horizontal turbine meter for their production, a meter that was capable of flowing 8,000 gallons per minute or more, and did not even start to register flow until about 65 gallons per minute. Pepsi closed that bottling plant and converted the building into a warehouse, which served a few bathrooms and maybe a small kitchen here and there. Although we never tried it, I always wanted to go and just turn on all the taps and just see if we could even reach 65 gallons per minute, because I had my doubts given how many fixtures there were that were being used. So in this situation, other than the base rate, that meter was not registering any consumption, and a 5/8 meter would have likely been more than adequate for that usage. Another possible indicator that there may be an issue in your system is if you have low pressure complaints. As you see in the photo here, another example of some pretty severe tuberculation there, but if you have a customer that's calling you complaining about low pressure, or if you have a number of customers complaining about low pressure, it's definitely well worth your time to investigate that. It may be something like the photo here with tuberculation, or it may be that you have a major main break and that's causing issues downstream. So definitely investigate those as they come in. We'd like to thank our friends at the Utah Water Research Laboratory for sending these photographs to us. What you're seeing in these images is a t-shirt that somehow became lodged in this 1.5-inch positive displacement meter. We can only speculate exactly how a t-shirt made its way into the system and eventually came to rest inside of this meter. But there are all sorts of things that make this industry so interesting, and we are truly never bored, are we? So, Audrey, again, you have a lot of great expertise in this field. Do you want to show us some more examples?
Sure. Thanks, Jonathan. Well, not all debris is from poor installation practices, line breaks, or a random t-shirt for that matter. This photograph shows you that bees, grasshoppers, and other insects have found an entry into your distribution system and ended up inside this multi-jet meter. These two meters are from the same batch as the meter you just saw on the previous slide, just further confirmation that not all debris comes from poor installation practices or line breaks. I can affirm that we all prefer clean, safe, and reliable drinking water without any insect parts. It's also very important for your utility to keep the area around your meter setting clean. It took many years for the roots shown in these two photographs to become intertwined around the meter setting and the pipes. These very expensive and difficult meter setting replacement projects could have been avoided. Even if your utility has a mobile AMR system or a fixed network AMI system, it does pay to periodically inspect all of your meter settings to prevent things like this from happening. Here's another example of what can happen if the area around the meter setting is not clean. This one comes to you from southern Oklahoma. I would hate to be the meter reader who had to open the lid on this one. Lastly, I think this photograph speaks for itself. If the meter register cannot be read, it's time to either replace the register or the water meter. And by the way, If you plan to replace just your water meter register, please use the correct replacement parts, or you're going to get some pretty wacky reads. Craig, you want to take us into theft of service?
Yeah, thank you, Audrey. I'd be glad to. Thankfully, most people are honest, and theft of service events are comparatively rare. But that being said, we'd just like to share with you some of our examples that we've collected through the years. And in this example of creative plumbing, you can see that it may be worthwhile to periodically pass through construction sites and verify that all temporary connections are being metered. And we've got a classic here. In this photograph, someone has removed the register assembly from this positive displacement meter, which is clearly a theft of service event. If you do not have an AMI system to automatically detect this type of problem, we recommend that you review the billing system output at the end of every cycle for either no usage on active accounts or for unusually low usage when compared to the historical usage at this service for the same period. Another creative plumber. Here's an example where someone has removed the water meter from the setter and replaced it with a union and 2 3/4-inch black pipes. An AMI system most likely would detect this within a day, and this is why it is important to watch for no usage on active accounts. And if your utility uses either electromagnetic or ultrasonic water meters, there will also be an empty pipe alarm transmitted through the AMR or AMI system. Now, we have an account holder who is truly committed to recycling. Instead of discarding an old washing machine supply hose, this customer discovered a very creative way at that, to repurpose that hose. This photo further illustrates why you need to watch for no usage on active accounts, as well as empty pipe alarms if your utility uses static water meters. And here in this example that many of you who work with water utilities have probably seen before, the account holder has reversed the meter in an effort to reduce their water bill. And this type of theft of service event is, honestly, it's often difficult to detect with a manual meter reading process, but it is very easy to detect if your utility has either a mobile AMR system or a fixed network AMI system. With either of these two technologies, you should watch for continuous reverse flow events. And static water meters will also generate an empty pipe alarm whenever a water meter is removed from service, even for just a few seconds. And we couldn't finish our section on theft of service events without having at least one photograph of the classic corporation stop valve where the dog ear has been sheared off so that the water service could be restored at the account. You can even see that the padlock has been tossed aside at the top right corner of the photo. And this is just one last reminder that your utility should be vigilant about either monitoring for usage on inactive accounts or assigning these types of accounts to a special reporting group and then monitoring those accounts for usage. Now, we have a question for you. If you find that someone has tampered with a meter setting, what does your water utility require you to do next? And we ask you to please check all that apply to your particular utility. And I'm Jonathan and Audrey, I'm really interested in seeing what the results are going to be on this poll question.
I am too, and it's we had an instance, Craig, didn't we, where of all places, the police department seemed to have a bypass that time after time just kept working itself open. So, if contact law enforcement is the primary go-to, I don't know what they did. They didn't do that on that particular project.
I don't know how those bypass valves just keep working themselves open. It's amazing.
It's a funny thing.
Yeah, I think new valves. That's what they need. New valves. Yep.
New valves. Yes.
All right. Well, it looks like many of you add the cost of the repair to the existing bill and levy a fine against the account. Very, very good. Very good. All right. Well, we surely have enjoyed sharing some of our favorite photographs with you and discussing some best practices for small and intermediate water meter management. And if you have any questions about this topic that you would like to ask us, now's the time to do so using the Q&A module on your console. So please let us know what your questions are. And I think I think, Jonathan, there's one question that's already come in, and it's, can you mount a positive displacement meter in the vertical plane?
Yeah, thanks, Greg. Yeah, so you can. There's been a number of studies into this where you can do it, and there do not appear to be any adverse effects on the registration of the meter. However, some manufacturers may prefer that you don't. So it's just something to be aware of. As if you intend to do that, make sure you pass it by your manufacturer. Just make sure that it's not going to affect any warranty or any projected operational issues as far as they are concerned.
Okay. Well, good answer, and we encourage you, if you think of other questions after the webinar, please forward them to us at bluewater@jci.com, and we surely hope that you enjoyed our team discussion on best practices for small and intermediate water meters, and we'd like to continue our focus on water meters by visiting with Dawn Groves, Martine Casillas, and John Baker of Camstrup. And Dawn, may I please start with you? What is your role at Camstrup, and how long have you been in the water industry?
Good morning, everybody. I'm Dawn Groves. I've been in the water industry now for over 20 years, and I have been with Camstrup just for the past couple of months, but been in the industry for a very long time. And thank you for having me today.
All right. Well, thank you, Dawn. And Martine, what is your role at Camstrup, and how long have you been in the water industry?
Good morning, everybody. My name is Martine Casillas, regional sales manager for Camstrup for the U.S. West. I've been in the industry for 23 plus years now, and I thank you for having us on today. Appreciate it, Greg.
Right. Well, thank you, Martine. And John, please tell us how long you've been in the water industry and what is your role at Camstrup?
Certainly, Craig. I'm also a regional sales manager. My focus is with system integrators and engineering firms nationwide. And I've been in the water industry for a little over a decade now, and with Camstrup for about a year.
Okay. Well, we're sure glad that all three of you could join us this morning. So tell us, when was Camstrup founded, and for how many years has Camstrup been making water meters?
And I'm going to go ahead and take this one here, Craig. So Camstrup was founded in 1946, and our founder, Olaf Camstrup, went on his own as far as a self-appointed technician in 1946, and that being 76 years and counting as far as a company, and established the company. The company has been driven by our late founder's mantra, there's always a better solution. And then to this day, those words continue to drive our people as a pioneer adjustments in smart meter solutions. So, yeah, it's 76 years plus, and the company was founded in Stilling, Denmark. And as of present day, we have over 1,600 employees. We're a global company. We do water, gas, electric, and BTU heat. And again, it's something that the mantra, is there's always a better solution, but also we have a new model that just think forward. So it's something that we take pride in, that people in Denmark take pride in, and we brought that model here to the United States.
All right. So when did Camstrup start making small ultrasonic water meters? I understand you've been in the ultrasonic meter business for many years.
Yeah, Craig, I can take this one. So it was actually in 1991, Camstrup made a strategic decision to be the pioneers of ultrasonic metering. And we've been doing it for over 30 years. We took a strategic decision to go with the ultrasonic measuring principle because we saw that was the future at the time. And we really took a big risk then moving forward with it. Now, of course, it's the technology that dominates the water industry.
Okay. Well, I know that you got your start in Denmark, and I know that the Dutch government is a little bit different from the United States government in that they require Camstrup to annually test a statistically valid random sample of water meters based upon years of service. And do these results indicate that either age or registration appear to have any noticeable effect on ultrasonic water meter accuracy?
No, Craig. Age which doesn't really appear to have any effect on the accuracy. And like you said, we do regularly test this, and we even publish studies on this. It's quite stringent over there. Residential meters have a 20-year accuracy warranty, and pretty much all this experience has made Camstrup confident that utilities using our meters won't have to worry about second trips to switch out defective meters. I know a lot of locations we find meters in basement sets, and customers never like having that. So we put a high price on quality and testing and maintaining the accuracy over the 20-year lifetime and more. So we're very proud to say that our global failure rate is less than half of 1%, and that number is actually even lower if you just look at the U.S. market.
Okay. Well, speaking of the U.S. market, when did Camstrup enter the North American market?
I can take this one. We entered the market in 2013.
Okay, 2013. And where are the water meters made that are sold here in the United States?
So what they are, they're made in Roswell, Georgia, and we established our U.S. headquarters in Roswell, Georgia, in 2018. We've got a 16,000 square foot facility. Within a year, we outgrew that, and we had to double that size into 32,000 square foot facility. We have assembly lines there. We have testing facilities there. And we have also a U.S. headquarters there. But as of today, just because of the growth that we have on a year-to-year fiscal basis, we're looking to go ahead and expand to a 100,000 square foot facility also.
Oh, wow. Wow, that's outstanding. Now, I know that Camstrup recently introduced both a 3-inch and a 4-inch ultrasonic meter. And do you have plans to release more large water meter sizes in the coming months or years?
And Craig, we do. And the reason being is that we'd like to have a turnkey portfolio, from residential sizes 5/8 by 1/2 and all the way to 10-inch. We're exploring introducing size in 6-inch, 8-inch, and 10-inch, the latter part of fiscal year of 2022 or early of 2023. So yeah, it is something that we're exploring. We'd like to do it. We'd like to have a turnkey solution. So that way we can give the customer the best case solution that they may need.
Oh, excellent. Now, when Jonathan was talking about selecting water meters earlier in the webinar, he mentioned battery life. So let's talk about battery life briefly. Now, we know residential water meters are designed for a 20-year battery life. So what is the expected battery life for the 1.5 and 2-inch meters?
Well, actually, for the 1.5 and 2-inch, it's actually a pretty short answer. The commercial meters are actually warranted for 10 years.
10 years, and
yes.
that also goes for the 3 and 4-inch meters as well, right?
That is correct.
Okay. Now, I know Camstrup offers a very unique mobile AMR and fixed network AMI system. And can you tell us what is different about your particular meter reading system?
And I'll go ahead and expand on that. Oh, go ahead, Don.
Yeah. Oh, sorry. You can take it. Go ahead.
So with Camstrup, what we do is that we have a dual band meter, and on the residential and commercial side. So within the meter itself, we can do both AMR at a 915 frequency, or if they wanted, the customer would want to go to AMI, they can go to a 450 frequency at a higher power. So they have the option of getting one meter that does both AMR and AMI with a dual band.
Okay.
One of the other things, Craig, if I may add to that,
Sure.
on the acoustic leak detection, that's also incorporated in the meter. It is a patented design by Camstrup. And what that means is the leak detection is not only for the homeowner, but it is also detecting leaks on your main lines. So you're able to pinpoint leaks throughout the utility front accounted for water. So that's one other nice feature of it.
Yeah, can you tell us more about that particular technology and some of the results that you've gathered with that new leak detection technology so far?
Yeah, I can answer this one. We launched ALD in the summer of 2020 here in the U.S., and we've seen a huge success so far helping utilities. We help them find distribution line leaks on mains and service connections, giving the utilities the most accurate real-time picture of their distribution system. We listen from the inside of the pipes, not the outside, because the ALD is fully integrated into the meter itself. So we can detect leaks on both sides of the meter, as Don was saying, which we think is very unique and very helpful. And we map this registered data in a simple and user-intuitive way, which is very helpful, of course, because it's not just having the data, but knowing what to do with it. And we know that there's currently a drought condition in a large portion of the U.S., so every drop counts, and we recognize that. So whether in low flow revenue or in the detection of water leaks in the distribution system itself, this technology will be able to determine where the leaks are pretty much before they surface. So thereby saving the utility and the customers, as Don was saying, from losing time, energy, water, and of course money, because we know that these meters are cash registers.
Oh, absolutely. I know where I live right now, we are in extreme drought conditions, and I sure could use some moisture of any type. But I do have a question talking about the leak detection system. I realize that the leak detection system may have more of a current draw on the battery. So is the battery life affected at all with the leak detection? Or are we still looking at the 20-year and 10-year battery life?
And Greg, I'll go ahead and take this. For the residentials that we have on with the acoustic leak detection, 5/8 by 3/4 up to 1 inch, it doesn't affect the battery life. So that's something that we take pride in. The type of technology that it is, it's integrated within the meter itself. So again, just like John said, we're not looking for leaks outside the meter looking in. We're looking for leaks within the meter itself and within the pipe itself too.
Okay. Does Camstrup? I know you're in the process of releasing large meter lines, and I'm just curious. Does Camstrup plan to have the larger ultrasonic meters become UL listed or FM approved for fire service at some point in the future?
Yeah. To answer that question, yes, we're looking at to do not only we have a 2-inch FM that's rated already FM approved. 3 and 4 in the process of getting approved, and then once the 6 and 8 and 10-inch come out here, latter part of the year, early 2023, it'll go through the same process of also getting approved too.
Okay. And I want to go ahead and turn it over to the audience. We've got 2 questions from the audience right now. One question is, what is the average distance of the AMI radio frequency? So I guess what the audience member is asking is, what kind of range are you getting from the endpoint to the collector once you're on the fixed network transmission?
And Craig, it's a good question, and I think with radio, it all depends on topography, cluster, and that noise. So typically, what we'll do is we'll do a propagation study on the opportunity, the utility, and see get some type of sites to go ahead and put the collectors up. But typically, they can range anywhere from 500 feet to a mile.
Okay. We have another question here. What is the accuracy of detecting leaks in the distribution system, and what is the typical distance that a leak can be detected from the water meter?
It's a real good question, and typically what the ALD feature does on the residential meter, it'll monitor, just like John said, it'll monitor the homeowner side, and it'll also monitor the utility side too. So it's a really good question, and it also depends on type of pipe material. But again, it can be anywhere from 50 feet, 100 feet to anywhere to 200 feet.
200 feet? Okay.
upwards.
All right. Well, if you have any more questions, please feel free to use your Q&A module. And we're almost out of time. And so if we don't get to your question today, we will definitely respond to you via email. And Jonathan, would you like to close this out?
Sure, Craig. Thanks. So we do have another webinar next month. Appreciate you joining us today. We do have another webinar next month. It's on March 16th. So you can see the link there on the slide. And unfortunately, that is not live, a live link that you can click on. But you can either jot that down or be looking for communication for the next webinar coming up. It will be part one of a two-part series regarding large water meter management. Obviously today we covered small and intermediate. We'll do large water meters for the next couple months here. We do want to extend again a very special thank you to Tom Kelly for your expertise and safety, and also for sharing us a little bit about the water buffaloes, and also to Dawn, Martine, and John from Camstrup for being here with us today. We definitely appreciate all of you taking the time to share your knowledge and expertise with us as well. If you have any questions for us, please do go ahead and submit them to us at bluewater@jci.com, or schedule a meeting with us. Happy to talk with you if you have a question, as I said, that may be a little bit bigger than something that can be handled in a simple email. And for future webinars, if you have any friends, colleagues that you believe would be interested in these webinars, or please forward the information to them so that they can be part of our group as well. And if there are any topics which may be of special interest to you, please let us know what those are as well. We have a roadmap that's charted out, but if there's a demand for a certain topic, we can certainly accommodate that. So let us know what's important to you and your utility. And thank you again for attending today, and we look forward to seeing you in March. Take care.
Yes, thank you very much. Thank you.